Hello students, now we are going to start A-levels differentiation, A2 differentiation, and what we are going to learn in this is differentiation of exponential functions, differentiation of logarithmic function, differentiation of trigonometric functions. Then we'll be discussing about product rule, quotient rule, and parametric equations and implicit differentiation. So this is what we do in A2 differentiation. So let's start with exponential functions. So for example, we have e power ax and we need to differentiate it. So derivative of e power ax is going to be e power ax into derivative of power, whatever power we have. So that is going to be e raised to the power ax into a, and you can write it as a e raised to the power ax. So that is basically derivative of e power ax. Now for example, if I have e raised to the power maybe 2x, so we need to differentiate e raised to the power 3x. So it's going to be e raised to the power 3x into derivative of this power, that is 3, right? So e power 3x into derivative of this power, so that is going to be 3 e raised to the power 3x, right? For example, we need to find derivative of e raised to the power 3x plus 6, so that is simply going to be e power 3x plus 6 into derivative of power, whatever power you have, its derivative. So it is going to be 3 e raised to the power 3x plus 6, right? So let's discuss some more questions. E raised to the power under root x, so that is basically e raised to the power under root x into derivative of this under root x, right? That will be e raised to the power under root x into 1 by 2 x raised to the power minus 1 by 2, which eventually becomes 1 by 2 under root x e raised to the power under root x. Okay. Similarly, in next question, derivative of e raised to the power x square, so that is going to be e raised to the power x square into derivative of the power, और इसको आप लिखोगे e raised to the power x square into 2x, so that is going to be 2x e raised to the power x square, right? Next, differentiation of logarithmic functions. Okay, when we have a logarithmic function, for example, that is basically derivative of natural log of ax plus b, that will be equal to 1 divided by ax plus b into derivative of the angle, so d by dx of ax plus b, right? Its examples are, for example, we need to find derivative of natural log of 2x plus 5, that will be equal to 1 divided by 2x plus 5 into derivative of this angle, that is 2x. Okay, 2x ka derivative, it's 2, so that is going to be 2 divided by 2x plus 5, right? Another question, we have to find derivative of natural log of 3x square minus 6x plus 8, that will be equal to 1 divided by 3x square minus 6x plus 8 into derivative of this angle, that is 6x minus 6. So my final answer is 6x minus 6 divided by 3x square minus 6x plus 8, right? So let's have another question, derivative of natural log of 2x plus 10, that is equal to 1 divided by 2x plus 10 into derivative of angle, that is 2x plus 10. So this will become 2 divided by 2x plus 10, right? So this is how we differentiate logarithmic function. It is simply natural log of ax plus b. So its derivative is going to be 1 divided by angle into derivative of this angle, right? So for example, it is natural log of 2x plus 5. So it's going to be 1 divided by 2x plus 5 into derivative of this 2x plus 5, it's 2. So similarly, if it is natural log of 3x square minus 6x plus 8, we are going to solve it in this way: 1 divided by 3x square minus 6x plus 8 into derivative of this angle, that is 6x minus 6. And the last one is natural log of 2x plus 10, that is equal to 1 divided by 2x plus 10 into derivative of 2x plus 10, which is 2. Okay, next after exponential and logarithmic, third thing what we learned is differentiation of trigonometric functions. Okay, so in differentiation of trigonometric functions, sine, cos, tan, secant and cosecant. So derivative of sine x is going to be cos of ax plus b into, you need to remember that whatever is angle in this scenario, we have to multiply it with its derivative. So sine of ax plus b would become cos of ax plus b into a. A is like derivative of this angle. Similarly, derivative of cos is going to be minus sine ax plus b into derivative of angle. Derivative of tan is secant square ax plus b into a, that is angle of derivative. Okay, derivative of secant is secant x tan x into derivative of the angle, right? And similarly, derivative of cosecant is minus cosecant cotangent x ax plus b into derivative of angle. So it's better you remember all these, though it is given in the formula booklet. Okay, so differentiation of trigonometric functions are going to be derivative of sine is going to be cos, and you multiply it with angle, derivative of the angle, and cos would become minus sine, tan would become secant square, secant would become secant into tan into definitely angle of derivative, and at the end cosecant is going to be minus cosecant into cotangent. So this is differentiation of trigonometric functions that we discuss in A2, right? So let's do a couple of examples of all these. So suppose we have to find out derivative of sine of 3x. Derivative of sine of 3x is going to be cos of 3x into 3, and you can write it as 3 cos of 3x, right? Similarly, if we need to find out derivative of cos of 6x, that is going to be minus sine 6x into derivative of the angle, that makes it minus 6 sine 6x. Okay, and similarly, if we have to find derivative of tan 3x, that is going to be secant square 3x into derivative of the angle, that is 3, and you can write it as 3 secant square 3x, right? So we will be using all these formulas, sine, cos, tan, secant, cosecant and cotangent for differentiation, and it is done in this way. Okay, what if we have such situation, derivative of sine square x, cos square x and tan square x? So derivative of sine square x is going to be, we simply apply power rule. Okay, that makes it power pehle, so it's 2 sine x into derivative of base, that is cos x. Similarly, cos square x will become 2 cos x into minus sine x, derivative of basically cos, that makes it minus 2 sine x cos x, right? And similarly, tan is like 2 tan x into secant square x. So this is derivative of sine square x cos square x, and tan square x. Okay, after this we have completed differentiation of differentiation of exponential, logarithmic, and trigonometric functions. Next, what we discuss here is a very important rule that is known as product rule. Okay, so let's give heading of product rule.